Right, so in this video I'm going to show you guys how the Arduino from the iPod Hi-Fi I showed in a previous video is actually programmed, so all the code that's running on it. First things first, I have some libraries I've added. You'll need to add this for the OLED display, uh, actually all of these, and then this one for the power monitor. I'll link in a card in the top right corner. Um, I have a video on how to make a power monitor. So basically this section is covered in a previous video, so I'm not going to go into any more depth here with regard to the power monitoring. Um, then up next, it's good to have some defines for the pins in case you burn out a pin or alright, you just want to use the nice names. And I find that defines are the best way to do it because constant int I'm not sure is converted to actual is changed at compile time. I would hope so, but I'm not sure if it actually saves the variables to the Arduino, which then has to always look up and right. So this is definitely going to be replaced. So the compiler will replace amp relay with 10 wherever it's found. So next up we have the display, and again this is covered in the power monitor video as well as the power monitor initialization. So next up I have a huge batch of global variables. So basically all I've used is our global variables. And this is because on a microcontroller of this size, right, you really want to minimize the workload. And having local variables will mean a lot of overhead. Well, not a lot, but it will add overhead, especially I do have quite a bit of calls going on. And I don't want to have that going on in the background. So first thing, we'll set the stuff up. So I would assume you're familiar with Arduino, but there's two main functions you have to have. I am not sure this is mandatory, but anyway, so one is setup and is run at the beginning of the program. So this is pretty short. And then the other one's loop, which runs infinitely. So this is basically, you could say while true and then start doing all of this. Exactly. So I'm basically initializing the pins. The Bluetooth LED and Auxin are input pull-up. So you can actually enable a pull-up internally, which is very nice. So if you connect nothing to the pin, it'll read high. And if you connect the pin to ground, right, it'll read low, right? So it'll overpower the internal pull-up. And we need this for the Bluetooth LED, right, because that is pulled low when it's on. So I'll actually put a picture on the right side of how I connected the wire that is going to the Bluetooth LED pin. And basically when the Bluetooth chip wants to turn the LED on, it pulls that pin low. Otherwise it leaves it floating or high. So yeah, same thing with the Auxin detector. I have it connected so there's in the jack there's two pins that I can connect to, one to ground and one to this pin. And so basically when you plug in the jack, it'll short those out. And again, we have our readings. The rest of this is relatively straightforward, so I'm just initializing some relays. I am actually driving them here, although I have functions to draw them because I want this to happen instantly. This is actually not used anymore, so could remove it. And then I have some functions, so this will turn the Bluetooth on, and we'll get to it a bit later. This will basically deactivate the charge relay, right? Remember, if you saw the complete video, at some point I showed the schematic, and the charge control relay is basically on, is set to charge the battery when it is de-energized. So basically that is what this does. Again, some more display shit going on. Perhaps we should talk about this font. So this is a very nice monospaced font. It doesn't work with white on black though, so this doesn't work. So it's pretty much like saying the font color is white. Normally this should make the background, black out the background of all the letters you put out. and it somehow doesn't. Power monitor, and then what do? Then we draw the battery outline and display it. But then again, these will be covered a bit later, so we won't go into them now. So loop, all right. And this is also not used anymore. So we have a delay just to make sure the stuff doesn't run too quickly. Um, we record the global time because we'll be using it to compare a lot of times and timings and whatnot. And I really do want to have a unitary time, right? For every tick of every go of the loop, we have the same time. All right, so first things first, we do this. We acquire all the signals, and let's go to that function. And it's here. So first we read the Bluetooth LED, and basically what we do here is we look for how long is the LED turned on. And I'll cut over to the next montage that actually shows the LED blinking.
Module. So that is LED 1, and the one to the left of it is LED 0. And excuse the mess, but I don't have any extra modules lying around, so I'll have to show you this in situ. So on the left side of the screen, I'll try to add the timing schematic, so how I set up the LED, and this is the searching state. Let's try and connect to it, and we should be connected. Alright, so now we're connected. The blinking is a bit longer. And I've spaced, I've done the blinks in steps of 200 milliseconds. And then if we play something, it is even longer. Let's disconnect again. All right, yeah, and let's get back to the main show.
Right, so now that we have the LED blinking, I should perhaps show you guys how the other ones. So if you don't program if you do not program the chip to blink a specific way, then the times will be these. So searching for connection will be fuck. So searching for a connection will be around 200 milliseconds, connected and paused about 100, and connected and playing 500. And there's going to be pauses between blinks that will vary, but this is not too relevant as we're just looking for the on time, and that is indeed distinguishable. What you will need to look out for if you try to implement this without actually going in and setting these timings is in this tab here, the LED events. There's also some events that make the LED blink. So for example, when the phone gets disconnected, it will also blink the LEDs. Or when, I think that's the main one that's been causing problems. So it will, for a moment, make your system think that it is actually playing. But anyway, so I removed those and changed the time so they're a lot clearer and well spaced apart. So there's 200 milliseconds between each. Then I'm looking for the Auxin, and I'm doing this, so checking whether the aux cable is plugged in or not, and I'm doing this every 500 milliseconds because I don't want it to toggle in. So when you're plugging in the wire, it's going to make connections for very short amounts of time, and then it's going to be disconnected again, and so on and so forth. So you want to debounce that signal is the technical term. So yeah, that is pretty much all that's doing there. External power, right? So if the current is less than 5 milliamps, so this number is actually in microamps. So if the current is less than 5 milliamps, then it must be that we're bypassing the power monitor completely with the power supply that's external, right? So nothing is seeping out of the battery, so to say. So yeah, in that case, we do have external power. If not, then we don't have it, and we also say that the battery is online, because if it isn't, and we're going to be dead in 1 second, so it doesn't really matter. So to check if the battery is online is a bit more complicated. So first of all, if external power is not present, we're in this line, so the battery must be online, because otherwise, again, we would die. So wouldn't mean too much to falsely set this variable. All right, so then we are having the charger plugged in, and we are charging the battery. So the relay is de-energized, remember? That's not really that important, but anyway. And then, yeah, so we have quite a bit of current, quite a bit of voltage, sorry. And the current is very low, right? And that must be, right, not connected, otherwise AC power voltage wouldn't float this high. True. Then second one, I actually commented the whole thing, so let's just read from there because I haven't read this in a month or so, so yeah. It is new to me as well. Exactly, so... Well, this voltage is fine that it's so low because we do have the current being very low, and even so, any of them are, so even if just the Arduino is running, it will pull more than 5 milliamps. So yeah, even at 24 volts, right? So with the LEDs being turned on and so on and so forth. So yeah, if that is not the case, then the battery must be online. And then again, so if charge is disabled and the battery is connected, then we will be reading the battery voltage, and that is all, right? And that is always going to be more than 20,000 millivolts, so 20 volts. And I just put 10 volts here just for the sake of, I don't know, why not? Then if the voltage is low, then the battery must be disconnected, because when we have external power, disconnect charging and have no battery, then this voltage is going to be pretty much zero. We're going to have some leakages, but there's going to be pretty low. So that is how this is going. This took me quite a while. I had to actually go make a little table and get everything sorted out because, yeah, that was a nightmare. All right, so let's go back. So we've acquired our signals, and let's see what we have basically at the end of this. So basically, state Bluetooth module, aux-in, and external power, and actually battery connected. That's this here. State battery online. All right. So, what do we do next? I'm sorry I can't jump. Like this doesn't let me jump, so this is very annoying, but yeah, it is what it is. Then we ask if new power monitor readings. So we read the power monitor, and this will return true every 500 milliseconds, and then when it does, we'll refresh the display. So yeah, let's go for new power monitor readings. It's not a lot going on. So basically, every time this is called, so every millisecond, I am adding a number, a reading to these numbers, and I'm recording how many I have added, right? So I don't expect this to be every millisecond every time, right? So, but anyway, so if the time passed since the last time we spewed out, let's say, a power reading is more than 500. Yeah, we do the averages. We set the low battery and negative amps flags. We reset all the variables and return 1. So what happens when we return 1? It goes into refresh display. All right, so this first thing divides the numbers by 1000, but in a, let's say, orderly fashion. So let's go to the divide right quick. So divide, where the hell is it? Divide by 10, 1000. So basically what this does can be ascertained from this right-hand column of comments. So 1, I'm basically dividing by 1000. I want to have dot and 001. So I want to always have 3 decimals, because for volts, these are going to be millivolts, and for watts, milliwatts, and the milliamps and everything, right? So although milliamps I'm showing directly, I'm not showing actual amps, but this was the main idea at the beginning. And I'm also adding a space at the end just to make formatting easier for the other functions. And yeah, this is pretty much all this does. And it actually removes the negative sign in case there is one, and that is actually taken care of separately. Yeah, let me know if someone wants the code. I could send it to you, so contact me in the comments. Don't have to actually copy all this shit. Um, exactly. So now we ask if the battery is online. We will show the watts consumed by the entire system. So either the watts when the system is powered from the battery, or the milliamp hours when the thing is charging. And if there actually is nothing there, then we will not show anything on the last column. In any case, I'm doing pretty much the same thing with the. This is in microwatts, and I really don't want stuff that precise. Plus, it fluctuates all the time, all over the place. So I don't even want to imagine how much the microwatts mean. So basically dividing it by 1000 and disregarding the decimals with this string operation. I could do it. I suppose I could do it in numbers. Probably should have. But too late now. Exactly. And this will be the variable used for watts or milliamps. And I'm putting milliamps in this watts in this case, and resetting the milliamp hour figure. And then when I'm charging, I'm computing milliamp hour seconds. And given that, exactly, so first of all, I have microamps and I have to convert those to milliamps. So it's divided by 1000, and I get readings every half a second, not a second. So I don't want milliamps over half seconds. I want milliamps over full seconds. So this is why the 2000. And then when we have more than 3600, we'll just add it to the milliamp hour figure and reset the milliamp hour second. And again, put it in this variable, which will later on get displayed. We erase all the screen, and this actually erases the buffer, right? The memory on the microcontroller that directly corresponds to the pixels on the screen. So it's basically a 128 by 64 array, and this would basically, I think so, right? In the simplest level, I wouldn't imagine they would do it differently. Would just put zeros on all of it. So it doesn't actually change anything on the display yet. Keep in mind. Then we're going to draw the battery outline, and I suppose now we could go check how that's done. It's just a two-liner. So round rectangle for the battery shape, and a square rectangle for the a rounded rectangle, and a squared rectangle for the tip of the battery. So now that that's done, we can start thinking about whether we have the battery present or not. So if we do have it, then we will fill it up with a bar, right, to indicate the charge. This is done by directly from the average voltage. I'm starting at 21 and going up to 24 when it's not being charged. And I'm starting at 23 and ending at 25 point. This is a bit too high actually. But there will be some losses. But anyway, let's put 200 here. So yeah, basically what this does is it allows us to show the full charge for a bit longer, and phones do this, a lot of devices do this. So show 100% for a while longer. When we charge, we don't really want to do that because we really don't want the person to disconnect the speaker until it's fully charged, right? And also the voltage will skyrocket very quickly for the first volt or two, so we're going to start at 2300. This doesn't work too well, to be honest. So this map function, I am not too happy about. And I think this is done through defines. I've read a bit about it, but I hadn't had a lot of time to fix this. But I am considering implementing my own because it's disastrous. Like from time to time, it just spews out garbage. Even if I constrain the variables. So I don't know. What these two lines do is basically when you have a bass heavy section in a song and the volume is quite high, you will have a pretty high draw. And this will pull the voltage down, right, temporarily. And it will go back up, especially if you turn the amp off afterwards. But I don't know, I really don't want to have the battery go all over the place. So I am disciplining it and having it just go down, basically, when it's not charging. And if it is charging, then there will be negative amps, and then, yeah, we'll just go on. Because this else is from this if. So yeah, we filled the battery bar. So first off with black to erase the previous one, and then with white to create the new one. Although, yeah, we don't actually need this. Yeah, this is from back in the day when I did not have the clear display. Wanted to make it a bit faster, but yeah, it did not happen. So, then again, we do something specifically when the battery is charging, and that is putting a little arrow outside or inside the battery bar to show it's charging. I don't really want to have the outermost layer of pixels blinking because I don't know that. Somehow I don't find that elegant. And if I would have had bigger bars, chunkier bars, then maybe, but the way I have it didn't really work. So I'm just putting a black arrow inside or a white one outside. I'm resetting the color to white in any case. And what this here does is it blinks the battery when it's low, pretty much. If, however, we have no battery present, we'll just say no battery inside the battery shape. So the battery shape is drawn, but it will not be filled. It'll just have the writing inside of it. So now we're going to write the text out. And yeah, if negative amps, we're going to put the negative here, so it's actually completely decoupled from this string. And yeah, basically just write the current, then the milliamps, the voltage, then volts, and what else are we doing here? Ah, yeah, exactly. So if the battery is being drained, let's say, we'll display watts. If it's charged, milliamp hours. And we also need, so a lot of work has gone into formatting the stuff so it looks really nice. So the milliamps, the milliamp hour figure will always be right aligned. So if it's very short, then we need it to be shifted quite a ways to the right. Yeah, and then basically if the charge is disabled, then we will not display absolutely anything here. So yeah. That's pretty much all. So yeah, this will ensure that this watts or milliamps will not be displayed to the OLED. And yeah, let me think. That is pretty much all of it. Draw the battery outline and let's go back to the top. So new power monitor readings and refresh display. So let's look at the variables. I'm sorry, this is so unorganized. I wanted to have these be right above the functions, but the compiler here is not smart enough to get all the automatically shift all the global variables to the top, so it actually compiles line by line. So if you have stuff in the wrong order, then it won't work because it'll say the variable is not defined, even though it is defined globally, but below it. So you can't basically do that, which is pretty bad. I'm pretty sure GCC can do that. Anyhow, so where were we? Signal acquisition. New power monitor readings, exactly. So these are the ones, the formats that are used by the library, made by Mr. Zanshin. So again, shout out for him. Awesome library. And I use a lot of these more specific types. I do actually like them because they're a bit more flexible than the long int, unsigned long types. So you can actually have int 32, which is the largest, then int 16, and then int 8t. And int 8t is basically a boolean, so boolean is int 8, or actually that's probably uint 8, but anyway. Refresh display. So what I probably should have mentioned is that these variables are strings of size 9. I think 8 would be enough, but what the hell. And pretty much all the variables defined. This only has, all right, and yeah. So then we have 3 more functions and we'll be done. So the display is refreshed. We have all the data, and so now all we have to do is actually control the entire system, right? And we do this with this automaton. So again, I'll probably add it to the right, in the right area here from the previous video, just to make it a bit more easier to follow. But yeah, pretty much this automaton amp state controls the amp, the Bluetooth module, and the LED. So in state 0, this would be the reset state, and we're basically almost never here because yeah, by the time everything is set up, right, the I squared C stuff takes a bit of time, right? By that time, the the Bluetooth module is on. So, but anyway, in this case, the amp is off. We turn the Bluetooth on, and the LED red. And then, given what state the Bluetooth module is in, we'll go to this state in this state machine. And obviously, if the aux is plugged in, we immediately go to state 3. All right, so state 1, Bluetooth module is powered up and searching. Amp is off, Bluetooth is on. And again, yeah, let's actually go and check this function out and the LED one, because those are quite nice. So where is it? Turn. All right, turn. So basically, this is a control box type of deal, and we have a lot of defines for the desired action. So I have amp on, amp off. And these have little tidbits of extra functionality built in, so which you don't have to mind. So you just want to say turn it on, turn it off, but then it knows that when you want to turn it off immediately after turning it on, it'll leave it on for 30 more seconds, just in case, right? You're typing on your phone, right? And that sends, so at least the iPhone sends just the key press and then stops the entire send, right? So you don't want to actually turn the amp on and off that quickly. And since it takes quite a bit of time to boot up, you also don't want to waste that time. So 30 seconds is still fine. We're not going to piss away too much power. And also at the beginning, only at the beginning, so now it's perfectly fine. The amp would stick. So actually, I'm actually turning it off. So it's a low side driven relay, so I'm turning it off by pulling the pin high. I'm waiting half a second, and then I'm checking, is it still on though, right? So there's the 5-volt regulator on there. I'm polling that with this digital read. And then if it still is on, then I'm going to toggle the relay on and off and on and off and on and on. And then wait a bit more. And if it still hasn't turned off, then we do it again. And then however much it takes. It never takes more than one go of this entire routine, but yeah, who knows what might happen, what the future might bring. All right, so charge off, and also I have basically returns at every point. So if it is already on, if it is already off, I immediately get out of this entire function. So this is what this return does. Even if it is a void, you can actually call return. I think you can actually even return a number, but that wouldn't make much sense. But this return just basically cancels, gets immediately out of the whole thing, so exits over here. Let's say charge on, pretty much the same thing. If it's already on, return. If not, do the relay thing. Bluetooth on, I have the same thing. If I turn it off, I want it to be off for at least 5 seconds, because otherwise the chip might see a dip in voltage and go into a battery protection mode, which is also not good. So it's pretty hard to get it up. So you can get it out of that, but you need to power it off completely. So yeah, that is why that is there. So turn. Alright, and you also saw turn LED, and this is done by this function, which is also very straightforward. So this is just being fed red, green, blue, off, and that is pretty much all. So all of these are defines, and these are actually actual characters. All right, so enough of that. So let's go back to the state machine. Or were we? All right, so we're connected. We're searching, sorry. So we're blinking the LED. So again, as you might have seen in the other states, if the battery is not low, we will be blinking the LED accordingly. So if it is low, then a bit later on we'll, actually not a bit later on, in the refresh display, we will actually run it. So turn LED off and turn LED red. This is why we don't want this state machine to control the LED in this case, in the case of the low battery. I could have done it here and probably should have, but if I do it there, it's synchronized with the blinking of the battery, so I did find that a bit more important. And then we have this blink LED function. So this is basically a transparent blinker, LED blinker, right? Normally you would have turn on, delay, turn off, delay. But we don't want to waste the time while we blink the LED, so basically it calls it and then it continues, and it relies on being called every millisecond for these times to be in milliseconds. Again, the precise timing is very unimportant in this case, right? The LED will be blinking in front, so if it's plus minus 5 milliseconds, I am pretty sure no one will notice. So the LED blinker has quite a bit of state variables, so let's go check the variables first. This is a mess of a video. I really don't like how the variables are structured, but I really couldn't do anything. I actually tried, right? Yeah, so we have the previous color, the state of each LED, it knows which state they're on, and the time they have been on or off for, right? So should be right here. Alright, so if the color is different, right, so we want to change the color, then we reset all the states and reset all the timers and remember the color, right? And then if we're blinking, what was it, blue, right? Let's say. If the blue LED is off, then we check, has it been off for the off time? And then if it has, then we turn it on again, reset the time, and actualize the blue LED state variable. Otherwise, it means it's not been off for enough time, so we just increment this. And then this is this bit covered. And then if the LED is not, if the LED is on at the moment, then we ask, has it been on for the amount of time we've wanted to be on for? And pretty much the same thing. So it does this for all the LEDs. It could have been a bit more. I suppose you could have shrunk this down to just one line with a bit more generic variables, but I don't know. I really like it this way because it is exactly how it works. So it's very easy to understand for this video and also for my stupid mind. So yeah. Alright, so LED is blinking, is where we're at, and there will be no more jumping from now on. So everything is pretty straightforward. So then we have this time alone function, time alone section. So if the Bluetooth module is not connected to anything, the way I want it to work is that it always will try to connect to the last phone. So when I leave the house, it loses connection, and then until I come back to the house, every 20 seconds I want it to look for my phone again, right? And it'll also show resetting Bluetooth on the screen just in case for the 5 seconds it's off, someone wants to connect to it. Just for the sake of completeness. And then turn Bluetooth on. Again, this is quite redundant. I might actually... Now actually this is important here. So even though it is mirrored here, we do need it here because otherwise the state will jump all over the place. And we don't want that. Exactly, otherwise time alone, right? So in this state, we'll constantly reset the Bluetooth module just in order to force it to connect to the previous phone. For the CSR8645, even yesterday I tried to do this in software to program the chip to actually do this, and there's absolutely no way. So I've tried absolutely everything. Second state, the Bluetooth is connected. Amp is still off because we're not playing any music. Not a lot going on. So Bluetooth LED is blue. What is it? The front LED is blue, solid blue. And yeah, apart from that, we just jump to the appropriate state given the inputs. And then case 3 is basically the money state, kind of. This is where we play the music. This is where the system is doing its thing. Amp is on. Um, if not low battery, then the LED is going to be green. Otherwise, it's going to be blinking red. And again, if we came here with the state Auxin being true because of the aux being plugged in, then we will go here and turn the Bluetooth off immediately because we don't want it to conflict with the aux signal. Otherwise, we turn it on, and again, this will be turned on every millisecond, but it will just return very quickly. And yeah, given that, we'll just yeah, go to the state if something changes. And then we have this power state machine, and yeah, basically this one controls the charge, and this has been quite a tedious if to program. And I also fucked up these curly brackets. I forgot them, and this if was actually tied in with this else. So yeah, this took like, it was pretty late though in the evening. So yeah. So exactly, first condition, we don't want to energize the relay if there's no negative amps, right? So if the system is not being charged, then there's no point in turning on a relay that will do nothing. Second condition, again, yeah, so basically, I think here I could have actually used the battery connected, but I did this first and then added these variables. But yeah, basically it's checking to see whether or not we're supposed to go into the not charging state, pretty much, right? So, and yeah, also, right, if the current is lower than 220 milliamps and it has to be larger since this is a negative number, it means we're almost done charging. We're going to wait a tiny amount, so 15 seconds. So 15 seconds, it's lower than 220 milliamps. Then we do go into the not charging state. Also, another thing that I've added actually a few hours ago, um, I am playing around with some very old lithium ion batteries, and they will heat the fuck up after 4 volts like fucking crazy. So if you really want to charge them fast, I think they would catch fire. But with 200 milliamps going to them, everything above 4 volts will be turned into heat basically. So the internal resistance skyrockets. And basically it would mean that when these batteries degrade, so the batteries I have in are also of unknown age. They're pretty good now, but I have no idea how much life they have left in them. Then it might happen that the current will never go below 220 milliamps. So in that case, we'll put a time limit on the charging, so it'll charge for 3 hours and then stop no matter what. So no matter what the current is. And if the voltage is very low and we have no external power, then we will go into the protection state. So this is basically the charge off state. It resets the state variables, let's call them, in the first state. State. And yeah, when we disconnect the power, we want to de-energize this relay, and so we go back to the first state. This case will never be used, more or less, because I have a protection circuit. But in case it fails or something happens to it, then this will kick in. And it'll basically de-energize the charge relay, turn off the Bluetooth, so that's going to save like, I think 10 milliamps or so. Turn the amp off, obviously. Decommission the amp state machine, right? Because if it's 10, then it'll never go into any of these cases. And blink the red LED frantically. And And yeah, so after the voltage is higher, then we're going to restore the state to both machines, state machines. And I think that is pretty much all of it. And again, I am very sorry for the fucked up manner in which this is laid out. I could have probably copy pasted it so that it's above, but then that would have been quite misleading. And yeah, that is pretty much all there is to it. So I'm sorry this took so long, but yeah, it is quite a bit of code. So have a good one, guys. And again, any questions, feel free to hit me up in the comments.